Okay, good afternoon, everyone. Okay, let's say I'm going to today going to do go to 1.2. Okay, 1.2 of chapter 1 from 4, where we will start with scientific investigations today. Okay, so in scientific investigation of 1.2 chapter 2, okay, we will look at types of graphs, types of graphs. Okay, we'll look at scientific investigation. All right. So types of graphs. This will be a very helpful when you collect data, put the data in a table, then later present the data in a form of graph. Because by looking at the graph, we will understand the relationship between manipulated variable and the responding variable. The whole idea is to understand the relationship between manipulated variable and responding variable, because whenever we do a scientific investigation, there will be manipulated variable. Most of the time it's axis X. The responding variable, due to the changes that we make, axis Y, responding variable. So to understand a relationship, we can show the relationship in a graph format. Okay, so this is a linear graph. You see here a straight line graph. It's called a linear graph. I'll come back in a while. Okay, right? Later we'll try to understand types of graphs. See here, okay? This is a linear graph. Since it's going through the zero here, okay, since it's going through the origin, this is called a linear graph, and it's called directly proportional. It's called directly proportional. It's a linear graph, and it's a directly proportional. Okay, and then if you look at it here, this graph initial stage look like linear. Later the graph value or the gradient decreases. All right, this graph also linear graph, but it is perfectly linearly inversely proportional. See my word, linearly inversely proportional. Okay, linearly inversely proportional. And then we will go through all these graphs again and again, no worries. This is called inversely proportional. So always when you represent a graph, you must tell, okay, see here, you must tell axis Y and axis X. What is their relationship? So you must tell here, resistance is inversely proportional to the cross-sectional area of the wire. Resistance is inversely proportional to the cross-sectional area of the wire. This is again directly proportional. Resistance is directly proportional to 1 over cross-sectional area of the wire. So when I compare these two, resistance and cross-sectional area, you can see here, since resistance is inversely proportional to the cross-sectional area of the wire, the same resistance is directly proportional to the 1 over cross-sectional area of the wire. Okay, we'll go through this part later in details, don't worry, okay? Okay, so first part of this subtopic, we have to look at graphs and how to identify graphs. The second part, we will try to understand the nature of these graphs, okay? Then in this subtopic, we will learn about scientific investigation, where you have learned this from Form 1, all right? Basically, there will be problems. We identify a problem, then we search for the control variables, we make a hypothesis, we plan the experiment, we carry out the experiment. In between here, we also will identify the aim of the experiment, what are the inference before we control the variables, okay? After we identify the problem, we can look for the aim, why we want to do this, what was the inference, and what are the hypotheses, what are the manipulated variable, and what is the constant variable, all is the controlling. Then hypothesis all there, planning, all this. Then we collect the data, then we put them in a proper table, then we analyze, we interpret by making a graph, then we come up with a conclusion, we write a report. So this is the whole story. Since all of you will have paper 3, Ujian Amali Bersepadu, so you have to, excuse me, you have to concentrate this part and try to understand all the methods of solving problems, especially scientific method and how to do a proper report. Okay, so observation, identification, form a hypothesis, carry out the experiment, record the results properly, analyze and interpret, and form a conclusion. So this is scientific method. I summarize the whole process, okay? Okay, so when you write, this is the method of writing, format of an experimental report, daytime, title, aim, problem statement, hypothesis, what are the variables, what are the materials, apparatus, okay, what is the procedure, 1, 2, 3, 4, then after the 4, you say the process was repeated like this, then you go to number 5, how you actually change the manipulated variable, results or observations, give a proper data in a table format, analyze and interpret, and finally come with a proper graph, the discussion and conclusion. So this is how we do the whole process, okay? Okay, so today let's start with a few examples again, okay? Okay, types of graphs, if you see here carefully. First, if you see here, P is directly proportional to T. V is directly proportional to I. Okay. Next, T square is directly proportional to L. You see here. So I repeat again. P is directly proportional to T because going through the origin, 0. V is directly proportional to L because going through the origin, 0. T square is directly proportional to length because going through the origin, 0. V is directly proportional to I. Okay. V is directly proportional to I. All right. Because going through 0. V is directly proportional to I because going through 0. And then this is a bit different. Okay. Initially, T and L linearly proportional. All right. Then later the value decreases. Okay. This is a perfect inversely proportional graph. So acceleration is inversely proportional to the mass. Acceleration is inversely proportional to the mass. Okay, this is a different graph. I plot two lines on the same graph. Okay, the first graph here shows that the value of velocity is constant. The second graph shows that the value of the velocity is increasing constantly. But why I use the word of acceleration? Because when you have a velocity against time graph, when you have velocity against time graph, okay, I don't have here. Okay, when you have a velocity against time graph, the gradient under this line, this graph, the gradient under this line here or this curve here should be the acceleration. So for the first graph, I realize here, this part here, velocity is constant. When the velocity is constant, if you remember what we learned the other day, guys, if you remember, acceleration should be final velocity minus initial velocity over the time. Acceleration should be final velocity minus initial velocity over the time. In this case, final velocity and initial velocity is the same. So if I take here 0 over t, it is still 0. So in a graph of v against time, right, the gradient of the graph represent acceleration. In the graph of v against time, the gradient of the graph represent acceleration. So if you see for the first line here, line number 1, v minus v over t here lah. If I say here this t1, you know, and this is t2, for example, right? Okay. So t minus t, I get a value, but v minus v is 0. V minus v is 0, so I get 0 acceleration. So now you should come up with a conclusion. You must tell yourself, when the gradient is constant, 0, constant pula. When the gradient is 0, then the acceleration is 0. So that's how we get the idea. So in this graph, we realize that the gradient is 0, 0 gradient, so 0 acceleration. But we see in line 2, the line B here, the gradient shows a constant value. This is the gradient. The gradient shows a constant value, therefore it's a constant gradient or uniform gradient, uniform acceleration. Constant or uniform acceleration because gradient is constant or uniform. All right. Anyone got any question based on this graph? Anyone? Okay, thank you. All right. So this one is a non-uniform acceleration because you see the gradient here is increasing slowly. Because as I said earlier, in a velocity against time graph, this gradient represent acceleration. This gradient represent acceleration. So when I see this graph, the gradient is increasing slowly. So it's a non-uniform gradient. So it's a non-uniform acceleration. You can tell it's increasing. Okay. All right. Done with that part. Okay. The basic formula of a linear graph, the basic formula of a linear graph, which you will learn in detail later in maths or at maths, okay, y is equal to, right, mx plus c. Okay, if it's a linear graph, straight line. Okay, what is y equals to mx plus c? Y represent axis y. In this graph, y is still y. Okay. X represent axis x. In this graph, x is still remain as x. M should be the gradient of the graph. M is the gradient of the graph. And C is the intercept here. Can you see this is the intercept? All right. C is the intercept of the line on axis y. It can be above 0 or below 0. So in this graph, perfectly C is equal to 4. C is 4, positive 4. What is the gradient here? The formula for gradient should be y2 minus y1 over x2 minus x1. I believe all of you have learned this in Form 3 last time. Okay, let's take this as second coordinate. So this is x2, y2, xy. So it will be 2 and 8. All right. And let's take this as the first coordinate, x1, y1. So this coordinate will be a perfect minus 2 and 0. Clear? So what is the gradient value here? So the gradient value here will be y2, 8 minus y1, 0 over x2 is 2 minus x1 here is minus 2. So gradient here is equivalent to 8 over 4, which is 2. This is how we calculate gradient. Gradient, you have to take 2 points of coordinates on a line and identify these two lines, these coordinates as x2, y2 and x1, y1. Okay, x1, y1. Then you solve the problem by using this formula given. Formula very simple. Gradient is equivalent to y2 minus y1 and x2 minus x1. So now I got the gradient value. I got ready. Title of y remain y, x remain x, and c also I found out. So what is the name of this line graph? So the name of this line graph should be, which is y equals to mx plus c, right? Y equals to mx plus c. So y remain as y, m is 2, x remain as x, plus c happen to be 4. So this is the answer. This is how we identify y equals to mx plus c. Okay, look at the first one. Okay, let's solve this together. Look at this line graph. Okay, current against voltage. So is it a line graph or is it straight or curved line? It's a straight line. Passing through the origin, yes. Yes. Gradient positive or negative? This is a positive gradient. Positive gradient. And interpretation of the graph. You must tell the current is directly proportional. Directly proportional to the voltage. The current is directly proportional to the voltage. Okay, let me share something to you all. Okay, when we have a graph, okay, what all of us should understand here is that, okay, see here. Okay, this is axis y and axis x. Okay, let's say we have a linear line graph going through like this. Okay, or there are a lot of possibilities. Another graph. Axis y, axis x. Okay. Another graph is going through the origin. Okay, then we have another graph pull up. Still graph of y against x. Okay. The graph look like this now. Okay. If you all notice something here, all right, notice here now, this line is inclined to the right, This line also inclined to the right. This also, dia condong ke arah kanan. So line ini condong ke arah kanan, inclined to the right. So all these three lines, or linear graph, shows that it is not passing through origin, so linearly proportional. Passing through origin, so directly proportional. Not passing through origin, so linearly proportional. It's a straight line. All these three are straight line. All these three are inclined to the right. So this is y is linearly proportional to x. Second one, y is directly proportional to x. And the third one, y is linearly proportional to x. Okay, based on these three, all of us should understand that all this graph shows their gradient is a positive gradient because the line here is inclined to the right, condong sengit ke arah kanan. So when we calculate the gradient, if let's say we happen to calculate the gradient of any one of these graph, all right, we will use the formula as m equals to y2 minus y1 over x2 minus x1. We will get a positive value. So as I said, all these three graphs shows that the gradient will be a positive value. Okay, then when it will be negative, see here. Let's say we have three other possible graphs. Okay, again, all the graphs are y against x, y against x, y against x. Okay, let's look at these graphs again. Okay, this graph is like this. Okay, this graph is going to the origin. Okay, and this graph is like this. If you notice all the lines in this page now, all the lines in this page now, if you notice here, okay, you see carefully, all right, this is inclined ataupun condong ke kiri, inclined to the left. Condong ke kiri, inclined to the left. Condong ke kiri, inclined to the left. So all these three graphs shows that the line is actually inclined to the left, So from this idea, we know for sure now the gradient of the line graph, all these three line graph will show a negative value. Will show a negative value. Of course, the formula remain the same. Y2 minus Y1 over X2 minus X1, but that's the value. It will be a negative value. All right. So if I see here, all right, the earlier graph, see here, all these gradients are positive. The second graph here, all these gradients are negative. All right. Okay. So this is the idea of the graphs. Where are we? Okay, the graphs. Okay, let's go through another example before we call it a day for today. All right. Okay, now. Okay, see this graph now. Is it a straight line graph or curved? It's curved actually. All right. Is it passing through the origin? Yes, it is passing through the origin. All right. The gradient is positive or negative? Still positive. All right. How to give an interpretation of this line? Okay, this one we have a special way to explain. We will tell as the current value increases initially. See, there's a long way to explain it. As the current value increases initially, the voltage value increases. The voltage increases initially, all right? But later you can see slowly it's decreasing. The current value started to decrease. So that's why you only use the word initial, maybe until a certain point only. After that, you can see slowly they are decreasing. So we don't have to explain that part, okay? All right.